Hello everyone, my name is Narsimha and I'm pursuing my BTech at Institute of Aeronautical Engineering College, Hyderabad. So I'm pursuing my BTech in a stream of computer science and engineering with a specialization of data science. So today, as a part of my AIT Tech Talk videos, in the subject of computer vision, I want to explain about a topic named context-based coding of ultrasound medical images using shape adaptation transform representation. So actually, this is the title of IEEE paper, and here down you can see the citation of that paper, which was published in the year of 2021 by these authors, three authors. And so, first of all, coming to the main abstract of what is the main abstract of this paper. So, in this approach, meaning this paper, the image compression process is designed to automatically detect and prioritize specific regions within an image that are considered regions of interest means ROI. ROIs typically represent areas of the image that contain critical details, important features, or information crucial for accurate interpretation or analysis. So first of all, what is the main application of this context-based coding of ultrasound images using shape adaptation, transform representation? For example, when we want to send an image or any data like PDF files or JPG files to any other person using the WhatsApp. For example, the image file storage means the size of the image file is very large, means it is in 2 KB, 3 KB. Example, let's consider an example. It is not being shared using the WhatsApp. We want to compress the image file. So the main advantage of using this image compression is the size of the image file will be reduced and it will be easily shared to other person. And another disadvantage of this image compression technique is if the image file is compressed, the quality of the image also will be automatically compressed. So this is coming to the normal real-time talk in our day-to-day life. For example, if the same strategy is used in the medical images, for example, if any scanning reports are there of liver or legs or any fractures or any bones scanning reports are there, the doctors want to minimize the image because the image files of the scanning reports are very large. Size of the image files are very large. So the database which is being used by the doctors are somewhat smaller in size. So to store many of the images, the image compression technique is being used on that images. So in that way, the size of the image will be reduced and also the quality of the image should not be degraded. So the special feature of the coding algorithm which has been proposed in this paper is it is based on identifying the ROS means region of interest pixels and division of the image into blocks which are classified based on their ROI pixel contents. Each block is coded according to its classification using discrete cosine transform DCT or shape adaptive SA. And in addition, they proposed a tailored interpolation scheme which significantly reduces artifacts created in ROI segments that are of irregular or non-continuous shape. For example, as we all know, which I have said before, when we are reducing the size of an image file, the quality of the image also will be reduced. So to get rid of that problem, the authors want to propose an algorithm, had proposed an algorithm that it, first of all, the algorithm will be detecting the ROS, means region of interest for this algorithm. So here you can see. So for example, this is a scanning report. And the main option is the doctors want to specify, means this is a region of interest, means the doctor want to look after this portion. So the algorithm first should detect the region of interest in this image and later on, when the image compression technique is being used, this part means the region of interest should be coded with high pixels and other part means this black structure, all this part is not useful part, should be looked after by the doctor. So these other parts which are not region of interest should be coded with low pixels. So in this way, the image compression will be done for the image, the size of the image will be reduced, and also the region of interest will be explored, means it will be detected easily by the doctors, even though the size of the quality of the image is degraded. So coming to the first of all, image compression. Image compression is the process of reducing the size of an image file, which I said before, to save storage space, facilitate faster transmission over networks, and enhance overall efficiency. Here you can see the two images, that is the original image of 2 MB size and compressed image of 176 KB. So here also you can see the quality of the images. and next. So coming to the image compression for medical images, which I have said before, image compression plays a crucial role in the field of medical imaging, where high quality images are essential for accurate diagnosis and treatment planning. Here you can see the two images of different, same images of different storage capacities. Coming to the region of interest. What is this region of interest? Theoretical way. Region of interest in medical images refer to specific areas within an image that hold clinical significance for analysis, diagnosis, or treatment planning. Which I said before, the doctor want to look after at this only this position, means this is the region of interest. The other parts are not essential for for declaring the treatment for the patient. So these regions manually outlined by healthcare professionals or automatically identified through computer algorithms play a crucial role in localizing abnormalities and enhancing image visibility and enabling quantitative analysis. So coming to this ROIs, this find applications across various imaging modalities, aiding in precise measurements, and also stored within picture archiving and communication systems. So coming to the, so here you can see, this is the brain image. For example, that you can consider, and this is scanning report, and this is the main region of interest. In this small part of brain, this much big information has been declared. So when the doctor want to specify, means want to look after this region of interest, when the image compression technique has been followed on this image, if this part is being degraded, means the quality of the image at this part is degraded, then the doctor can't get to a final conclusion about what is the suffering problem of the patient. So this is the main part of ROI, means region of interest to look after it. So come to the ROIs. Next, flow of process. So the steps involved in the process are, means what are the steps being involved in it? Image segmentation, ROI detection, bit allocation, compression, coding and storage, decompression, presentation of analysis. This is the flow of the process. So coming to the one by one step separately. First of all, coming to the image segmentation. The algorithm begins by segmenting the input image into different regions. Various segmentation techniques may be employed, such as clustering, edge detection, or region growing methods. So, for example, let us consider this image. This is the region of interest. So, first of all, the algorithm is going to divide this image into different parts, different segments. And after doing these segments only, the ROI detection will be easily available for the algorithm. Next, second is ROI detection. Following segmentation, the algorithm identifies and isolates regions of interest based on predefined criteria. Means actually the algorithm, automatically the algorithm will be provided with the databases. Means the training of the algorithm will be done in the past experiences. After the parameters, means for example, to the leg, the bones, the gaps between the bones are declared as region of interest by the doctors. For the skull, the bones, the small minute bones are declared as a region of interest. And for the brain, which I have seen, which I have shown before, the part which is very valuable in the brain is stored as region of interest to the algorithm. So basing on the criteria, predefined criteria, the algorithm is going to identify the region of interest. These criteria could include specific analytical structures, features, or areas relevant to the intended application, such as medical diagnosis. Third one, bit allocation. The algorithm allocates different bit rates to the detected ROS and background. ROS being of higher importance are assigned relatively higher bit rates to perceive detailed information during compression. Next, compression. The actual compression process begins where the image data, including the ROS and background, is encoded using the assigned bit rates. So these bit rates are encoded based on the ROS, means our region of interest parts are encoded with higher amount of bits and the other parts are encoded with lower amount of bits. So common compression algorithms like JPG, JPEG are may be employed with modifications to accommodate the varying bit rates for different regions, as I have said before. Coming to the next one, coding and storage. The encoded data is then further processed and coded before being stored or transmitted. The resulting compressed image files reflects the prioritized bit rates as assigned to ROS and background areas. Decompression. During image retrieval or analysis, the compressed file is decompressed. For example, the doctor has, means the medical diagnostic assistant has to compress the image file and is stored in the database. If the doctor want to look after the image very clearly, means the decompressed image, the original image want to look after by the doctor, then the process of decompression can be applied on the compressed image. by which the doctor can be analyzing the original image. Last one is the presentation or analysis. The decompressed image is presented to the user or used for analysis. The prioritized representation of ROIs allows for enhanced visibility and detail in the areas of interest, which is particularly beneficial in applications like medical imaging. So coming to the conclusion of this part. So this ROI-based image compression process optimizes the use of bits, focusing on preserving critical information while efficiently reducing the size of the image file. The main motto of this lecture or the title which have been showing the first slide is the size of the image file of the medical image should be decreased, but the quality of the region of interest should be not decreased. Means the storage capacity of the database should be utilized in a perfect way, and also the doctor can access the original image and the compressed image when he want. So this all works will be done by only one algorithm that is proposed by the authors in this IEEE paper. And also the tailored approach is especially valuable in domains where specific regions carry diagnostic significance and demand higher levels of detail. So thank you, friends. I hope my lecture is useful for you. Thanks for watching. Thank you.